Assalamualaikum and a very good day to all of you. So today we'll talk about Ethernet switching. So Ethernet is one of the two LAN technologies that we use nowadays. So for LAN technologies, usually we will use either Ethernet LAN or wireless LAN. So what Ethernet LAN means, it is the LAN communication that use wired connection, which includes twisted pair or UTP cable, fiber optic links, and also the coaxial cables. So basically, first we need to learn about the Ethernet frames. So Ethernet frames operates in data link layer and the physical layer. So basically, it is a family of networking technologies which is defined in the IEEE 802.2 and 802.3 standards. So in here, Ethernet actually supports data bandwidth of 100 megabit per second if you are using the twisted pair, or 1000 megabit per second for the twisted pair, and also the fiber optics, 10 gigabit per second, 40 gigabit per second. So basically, it supports various data bandwidth up to 100 gigabit per second. So if we look in the diagram here, the Ethernet standards is defined both the layer 2 protocols and the layer 1 technologies. So if you look here, it works both on the data link and physical layer. So in the data, for the Ethernet frames to work, it works in two data link sublayers. So basically, for the internet, it uses two separate sublayers of data link layer to operate, which is the first one is the LLC sublayer, which is the logical link control, and the MAC sublayer, which is media access control, as shown in the figure. So let us look at the logical link control sublayer. So this sublayer is defined in IEEE 802.2. So what it does is it will allows communication between the networking software on the upper layers, which is from network layers to the application layers, and also the device hardware of the lower layers. So basically, the LLC sublayer will place information from the upper layer in the frame to identify which network layer protocol is used for the frame. So this information will allow multiple layer 3 protocols such as IPv4 and IPv6 to use the same network interface and the same transmission medium. So next we have the MAC sublayer, which this sublayer is defined in 802.3, 802.11 or 802.15. So basically, the MAC sublayer is implemented in hardware, and this sublayer is responsible for data encapsulation and media access control. So if we look here, this sublayer actually provides data link layer addressing and is integrated with various physical layer technologies. So like for example, Ethernet IEEE 802.3, not dot, is supposed to be 3, supports various Ethernet standards such as for the fast Ethernet, gigabit Ethernet. For the wireless 802.11 will support various wireless LAN standards for different types of wireless communication. And for the 802.15 will support wireless personal area networks such as the Bluetooth and RFID technology. So the MAC sublayer is responsible for data encapsulation and accessing the media. So basically, there are three data encapsulation, which is first the Ethernet frame. So this is the internal structure of the Ethernet frame, and second, the data encapsulation for the Ethernet addressing, where the Ethernet frame will include both source and destination MAC address to deliver the Ethernet frame within the same LAN. And finally, we have the Ethernet error detection, which will include a frame check sequence trailer, which will be used for error detection. So I will explain about the media access first. So under MAC sublayer, alright, under MAC sublayer, so as shown in the figure, you can see the specification for different Ethernet communication standard. So you can see here we have for the LSC we have IEEE 802.2. For MAC sublayer we have 802.3, and then even for 802.3, why previously in the previous slide it shows 802.3, 802.11, 802.15, but in this slide we only talk about 802.3 because you have to understand the Ethernet LAN, Ethernet switching deals with wired connection. So whatever the standards that we shows here is the standard that being used for the wired connection. So for example, IEEE 802.3U supports fast Ethernet communication. For IEEE 802.3Z supports the fiber, and for the 802.3.3AB supports the gigabit Ethernet over copper, right? So and so on and so forth. So basically, hence the reason why you see here the supported standard defined in the MAC sublayer is 802.3, because we are now talking about the wired LAN, the Ethernet LAN. So the legacy Ethernet previously used a bus topology or hubs, which is basically this device, the hub device or the bus topology, use half duplex medium. So as we know, when the medium is half duplex, so only when a sender or receiver, only one party can transmit the signal or the packet at one time. So if both parties, sender and receiver, are trying to send a frame at the same time, so basically collision will happen. So here, the Ethernet over half duplex medium, how they will avoid collision from happening is by using contention-based access method, or which called as carrier sense multiple access collision detection, or CSMA-CD. However, nowadays, most of us are instead of using hubs, we are using switch for the Ethernet lines. So switches usually operate in full duplex mode. So full duplex communication with Ethernet switches does not require access control through CSMA CD anymore. Alright, so now let us look at the Ethernet frame field. So the minimum Ethernet frame size is 64 bytes, and the maximum size is 1518 bytes. So basically, in the calculation, the preamble field is not included when we describe the size of the frame. So any frame that is less than 64 bytes, so the 64 bytes starts from the destination MAC address. So any frame less than 64 bytes in length is considered a collision fragment and is automatically discarded. Because why? Because they do not have the information, the required information to for the frame to be transmitted properly. So the frame with more than 1,500 bytes are called as jumbo frames or baby giant frames. So if the size of a transmitted frame is less than the minimum, which is 64 bytes, or greater than the maximum, which is 1518, so the receiving device will automatically drop the frame. So drop frame are likely to be the result of the collision or other unwanted signals, or because of the noise interference during the transmission. So because of that, they are considered invalid. But if you have jumbo frames, so it is usually supported by most fast Ethernet and gigabit Ethernet switches and network interface card. So if we look into the structure here, so the preamble consists of 7 bytes, and the remaining 1 byte is the start frame delimiter, or also SFD here. Okay, is called as start frame delimiter, or also called as start frame. So basically here, um, if we look into the data, okay, if we look back into the data, so data structure, so what we have in the data structure is actually the information that is encapsulated from the higher layer, which is a generic layer 3 PDU, or more commonly known as the IPv4 packets. So all frame must be at least 64 bytes long. So basically, if a small packet is encapsulated, additional bits, which is called a pad, are used to increase the size of the frame to this minimum size, which is the 64 bytes. And then we also have the frame check sequence, the last part of the Ethernet frame, which is used to detect errors in a frame. It uses a cyclic redundancy check, or CRC. So the sending device include the results of a CRC in the FCS field of the frame, so that whenever the receiving device receives the frame, it will generate a CRC to look for the errors. So if the calculation match, it says that no errors occurred. If the calculation do not match, so basically it indicates that some part of the data section, data field, has been changed, and therefore the frame is dropped.